take an extra day and be comfortable with it. So, the warm-up question on the left is asking you guys to solve for just the x value, and then the right, again, is trying to make sure you're in the right mode. So if you do sine of 30, that's 30 degrees, it should be 0.5 or 1/2. That's kind of how you know you're in the right mode. If it's not, then we need to switch your modes.
Definitely not.
Sine mode. Highlighted. So good question. So guys, listen up please. The question was, when do we know which mode to be in? So I guess a lot of times with graphing, and if you're graphing with sine, cosine, or tangent, so the sin, cos, tan buttons, typically you'll want to be in radians if you're graphing. But we're going to start talking about angles. And when we talk about angles, most of the time we're used to seeing them in degrees. Eventually we're going to learn about something called radians. When they're in radians, then we want to be in radian mode. So I know students who use their calculator for physics as well. You have to switch back to degrees because typically we measure things in degrees. But again, radians is a method that we're going to use later this chapter, and we'll talk about those. So just so you guys know, this last half of chapter 2 is basically, I think it's like one section, maybe 1 or 2 sections that we're dragging out over like a bunch of days. And we're going to take like a quiz on just that group of things because it all goes together. It's all talking about trigonometry. And so we're going to kind of like do one section of our book, but like spread out over the course of a bunch of days. So in the warm-up question, looking for x, how did you guys go about solving for that? Do you remember? Okay, so what, do you know what you're using when you do that? Yeah. So when we're solving for this, what Dexter mentioned, and he started telling me what he did already, which was great, but I just said, like, what were you doing there? And so that was Pythagorean theorem. We use that when we have two sides of a right triangle. So the Pythagorean theorem is what we can do if we're missing the side of the right triangle. And he mentioned the hypotenuse. That has to be the longest side, so that's our C. And our x and or our A and B don't really matter. So I'm going to put them in either spot there. So I go to put this in. And so he said he basically did 52 squared minus 15 squared. And that gave him, and yeah, probably need calculator, like I said, we probably want calculators for today. If you can do 52 squared in your head, you're probably some sort of genius. And then in order to solve for our x, we're going to take the square root of that number. And I get like a decimal of 49.8, depending on what they want me to round to. We'll go 49.8. Okay, so that's kind of a basic geometry. Maybe even you saw that in 8th grade math. Like Pythagorean theorem is something that hopefully you guys have seen before and are comfortable with. Again, making sure you're in that right mode. So in your calculator, most of the little scientific calculators default to degree mode. Most of the graphing calculators default to radians, which again, so talking about radians, graphing in radians is usually best. And then later we'll talk about measuring with radians, because radians actually work really nicely. Like it's kind of strange, like there's a lot of kind of interesting stuff that kind of comes with them. Math people interesting, but still interesting. So making sure you're in the right mode is crucial here. So we're going to talk about SOHCAHTOA today. I saw some of you guys write that down already. Just to remind you guys what that is. And we'll solve some equations with SOHCAHTOA and get comfortable with it. Because next class requires that we're comfortable with that. Or next lesson. And I didn't want to kind of assume that you all were good on it. So it's been a while. So the reason why someone came up with the rule of SOHCAHTOA is that they wanted to help students remember the different ratios. So the O, H, and A all stand for a different piece of the triangle. And everything is based off of the angle of reference. So this is our point of reference. So we're talking about angle A. I'm going to label everything based off of angle A. Now we'll never take the sine, cosine, or tangent of the right angle. So either A or B in this case could be our angle that we use. So I'm going to say never 90 degrees. So based off of that angle, I'm going to label my sides. What side do you guys want to label first? Doesn't matter. Which one do you want to label first? You really want to label, I would say not to label that one first, but you could.
The hypotenuse.
Let's label the hypotenuse first. I like labeling the hypotenuse first as well. The reason why I don't like labeling the one you suggested first is because that's the only one that I feel like the name is a little bit like, oh, why do you call it that? But hopefully it makes sense. The hypotenuse has to be always where the hypotenuse is. It's across from the right angle, it's the longest side, so that's the H. So when we see H here, that's what it's referencing. So then the other side is actually opposite because it's across the triangle from that angle. So our opposite side, and that's what the O stands for. And then the side that Patrick, I told him that basically there's no wrong answer, then he picked that one. And this is the adjacent. And the word adjacent means next to. It's basically the side that's not the hypotenuse. So I usually label that one last, but it's fine, whatever. And so what this ratio tells us is, or these little SOHCAHTOA rule tells us what goes with what. So opposite goes with hypotenuse. It's opposite over hypotenuse. The next one is adjacent over hypotenuse. And then tangent is opposite over adjacent. So I saw Dawson write it on the top of his page, SOHCAHTOA. Every single time we're dealing with right triangles, writing SOHCAHTOA down, it's just smart. It's just like, it's using an acronym that's gonna help us. So the first few problems here, like I said, we'll probably just do a little bit of this. I might just do up to example 4 if we have time. Just solving for the sides. So we're going to use SOHCAHTOA to set these up. And so when we know something about the angle, we want to label everything based off of that angle. So they used angle A in this case. So in this first example, I'm going to use angle 10. Because that's the angle I know something about. Now technically, I could figure out what the other angle is, because I know the angles of a triangle add up to what? 180. So I should be able to figure out that this other one would be 80 degrees, because this is 90, but I'm not going to use that right now. So if this is my 10, I'm going to label everything based off of 10. So again, here's my hypotenuse. Opposite, adjacent. Now, based off of what I have and what I know, what trig ratio do you guys want to use?
Tangent.
Yeah, we're going to use tangent because I don't know the hypotenuse, nor do I seem to care about it right now. They didn't ask me for it, and they also didn't tell me anything about it. So we're going to use tangent, so TOA. So tangent of 10 degrees. And again, we're using degrees, so that's why we're in degree mode. If we were using radians, we'd be in radian mode, but we're not. So 10 degrees is opposite over adjacent, so x over 16. Now tangent of 10, just like E was a number, tangent of 10 is a number. It's a value, so that those two can't be separated. So tangent of 10 is its like own thing, and we're trying to solve for x, so what are we going to do? How are we gonna solve here?
5 by 16.
What's that?
5 tangent 10 by 16.
Not divide. Yeah, Dawson?
No.
Yeah. So we want to multiply because it is being divided. So we're going to do 16 times the tangent of 10. And again, you're going to need a calculator for this because, I mean, again, if you're able to do these tangents in your head, there's some sort of thing going on in your brain that I don't understand. So you end up with, and again, your answers should make sense. That's one of the things I like about trig, is your answers shouldn't be like, 5,000 and you look at it and be like, well, that sounds wrong. I got 2.82. Does that sound like what you guys got as well? So, and if you look at our drawing, and our drawing might not be great or drawn perfectly to scale, but it should make sense. Okay? So x is 2.82. So why don't you guys try letter B if you haven't already. Try to figure out which trig ratio you should be using. And we do have a worksheet, so I'm just going to assign part of the worksheet for homework. All right, so which trig ratio did you use for letter B? So use so you probably use sine, so this is our opposite and our hypotenuse. Again, I don't know the other side, nor do I really care about it, so I want to use the side the one that has opposite and hypotenuse, which is so, technically sine. So sine of 25 degrees is my angle, and I'm doing opposite over hypotenuse. Oops, I could write that hypotenuse correctly. And so x is being divided by 10, so instead we're going to multiply by 10. And again, you're going to need your calculator for that. Again, your answer should make sense. I'm picturing it's going to be something less than 10, so the hypotenuse should be their longest side. And we get 4.23. Okay. Next one. We don't want tangent to feel left out, or whatever one should be left out. Cosine, right? We haven't done cosine yet. Are you guys remembering this? This is so bad? Or not? Okay. Not just letting the people who remember everything answer all the questions. All right. So the next drawing is drawn a little weird because of the fact that it's kind of a little that angle's so large that it kind of maybe looks a little strange here. So this is our 73. Again, here's my opposite. Here's my hypotenuse. And then this one's my adjacent. So I don't need my opposite. So again, we haven't used this one. Doesn't mean that that's why we're using it, but it happens to be the one that we're going to use cos, which is cosine. So cosine of 73 degrees is going to equal our adjacent over our hypotenuse. So we're going to multiply each side by 6. And again, that's one of the things you guys want to be careful about if your answers are not making sense at all. Like if your answer is wow, that doesn't sound right for that side length. And let's say you share a calculator with somebody else, make sure that you're in the right mode. That's usually your indicator that something has gone wrong, that you're not in the right mode if your answer doesn't make sense. So example 4, I'd like to talk about for sure, and then we can decide if we just want to, like the rest we can kind of hold off on. But like I said, I have a worksheet for you guys. I'm probably just going to give you it's like 8 questions. So let's look at example 4 though, because example 4 is a little more complicated. And if you get it set up, I think you'll see why it's more complicated. So far, I would say we've done like kind of your run-of-the-mill trig, but at the same time, example 4 is a little bit trickier, because when I go to set this up, I label everything. So we have opposite and hypotenuse, so I know I have to use sine. Sine of 15 is going to equal 16 over x. Why is this not great for us?
You can't just straight up multiply.
Yeah, we don't get to just multiply by 16 to get rid of that, because the x is in the denominator. Because it's the opposite over the hypotenuse. And even if, like, let's say you were like, I'm going to get fancy, I'm going to change my perspective, I'm going to put it over here, that angle, it's still the hypotenuse. It's always going to be in the denominator. Hypotenuse will always end up in the denominator. So we have to figure out what to do now. There's a couple of different ways to solve a problem like this. Any thoughts?
The other angle.
But you can find, well, it's okay, let's talk about that real quick. So finding the other angle, so that one would be 75 over here. If we know 16, we know x. This is still going to be, now this is going to be cosine, but the h is still going to be in the denominator. I mean, you could find the other side and then do Pythagorean theorem if you wanted to. I think I don't think we have to completely go away from this. Any thoughts on how we get that x out of the denominator? What's the strategy here? Yep.
You would, so you would multiply both sides by x and divide both sides by sine of 15.
Okay, so I'm going to show this way and then I'll show another way. Either one is fine, whatever you prefer. So he said, let's multiply each side by x. So the x's will cancel. Over here, I'm going to have x times the sine of 15 degrees. Remember, sine of 15 travels together, so keep that together, will equal 16 over here. So in order to solve for x now, we need to divide by the sine of 15, because it's being multiplied. So we're going to divide by the sine of 15. And again, that travels as like a whole group, so you can't separate those off. So you're going to take 16 and instead divide by the sine of 15. And again, make sure your answer makes sense. And you might have to put sine of 15 in parentheses, I don't know. I got 61.82. Is that what you guys got? I want to show you guys one other way in case like you're not like super excited about that way. It's probably really, really similar. So I'm just going to show it as well just to give you another option. But one of the ways you're going to have to do this, so we just have to. So I think when I teach this in trig or geometry, a lot of times we have done things with proportions already. So proportions is when I have two fractions that are equal. If I have two equal fractions, so I made this sine of 15 over 1. What I can do now is cross multiply. And this is essentially what you did, it's just in a little bit different way. So by cross multiplying, I got the same thing that he got just like with a different way. So now I have to divide by the sine of 15. And we do a lot of these problems, so eventually you're just gonna learn when the x is in the denominator, I have to divide the two. But either way, we should end up with 61.82-ish. Okay? Do we need another example of that, or are we okay? Okay, all right. So what I'd like to do, you guys, I'm gonna give you guys a homework assignment, but I'm gonna give you just part of it. If for some reason you're really great at this and want to work ahead, you're welcome to, but feel free to wait with us. So what I would like to assign for our worksheet here, so we're going to do just numbers 9 through 16. We're going to talk about solving for the angles and stuff next time. And again, if you remember how to do it,